Hi class, so in this video I'm going to review with you how to name ionic compounds and how to write formulas of ionic compounds. So there are two things that you need in order to watch this video. You need obviously the piece of paper you can take notes on, but also you need a periodic table and your list of polyatomic ions. So there are ions, charged atoms, right? Ions are charged atoms. And some of them are monoatomic, meaning there's one atom. Some of them are polyatomic, meaning they are made out of many atoms. Your periodic table looks like this, and your polyatomic ion list looks like this. And it basically has a list of names, and you don't have to memorize these. You'll always be given these on the quiz. And it has their formulas with their charges in the top right hand corner. So you'll need both of those sheets in order to totally understand what's going on. And I've posted both of these handouts, both the periodic table and the polyatomic ion list, on the Moodle website, and will be posted on the Teacher Web website as well. Okay, so you need to know what the patterns of charges are. So as you learned in the previous activity, the charge of group 1 ions are +1, the charge of group 2 ions are +2, and the charge of group 3A or 13 ions is +3. You have to memorize this pattern, but obviously a very easy pattern to memorize. Group 7A or 17 on this periodic table is -1. Group 6A, the atoms, when they become ions, they're -2. And in group 5A, they're -3. Now, these are called, in the middle, the transition elements. Their charges are not easily predictable. So, except a few of them are, and these are the exceptions. Zinc is always +2, and cadmium is also always +2, and silver is always +1. Okay? Now, you also have some ions down here, look kind of shaped like a little car, right? And I can draw a little car right there. And those ones are also, these ones are variable charges. So even though they're in this region on the periodic table, they're called the representative elements. These can be multiple kinds of charges. So these are the exceptions to the I can predict it rule, and these three right here, right there, are the exception to the rule of I can't predict it. So zinc is always +2, cadmium is always +2, and silver is always +1. Okay, so now let's take a look at how to write ionic formulas from the names. The first step is you write each ion indicated from the name. Then you crisscross the charges and you reduce. Notice that these last two steps are the same as the previous quiz. So let's try it out. We have calcium chloride, and so we look up on our periodic table calcium, and we notice that it is in the second group, so we know it has a 2+ charge. So we write Ca 2+. We know, if we look at our periodic table, chloride is in group 7A, so we know that the ion will be -1. And now we crisscross, right? Put that number down there, put that number down there, and we get our formula, CaCl2. And that's how you get the formula from the name. Okay, let's try the next one. Magnesium phosphate. So, we look at our periodic table. Magnesium is in group 2, so it's Mg2+. And if we look for phosphate, there is no phosphate element. There's a phosphorus, but that's not, it would become phosphide if it wasn't an ion, so we'll get to that naming part later. So we need to look at our polyatomic ion sheet. So we look up phosphate and notice it's right there. PO4 3-. We'll write that in. PO4 3-. We put that charge at the bottom, we put this charge at the bottom of the other element. So the answer is Mg3 PO4 PO4 2. And there's our answer. On the next question it says iron 3 sulfate. Now, if you notice where iron is on the periodic table, it's in that transition area where the charge can't be easily predicted. So in the names, what is done is you have a Roman numeral that signifies how positive it is. So it's Fe3 plus, and then we look at our periodic table and notice there is no sulfate atom. So we look at the polyatomic ion list. Sulfate it's SO4 2 minus. So we'll write SO4 2 minus down. SO4 2 minus, and now we're going to crisscross the charges. Fe3 SO4 Fe2, so we'll crisscross that, right? Fe2 SO4 3, and there's our answer. In the last example for this part, we have copper 2 bromide. So we notice that copper is in this central area, which is the charge cannot easily be predicted. So there's a Roman numeral for you to help you predict, to help you tell what the charge is. So it's Cu2 plus, and we look at bromine for bromide, and you notice that it's in group 7. So it is Br minus. Now we crisscross the charges, and it's Cu with a 1, but we don't write the 1, and Br2, so that's copper 2 bromide. Okay, so in the next section, how to write ionic compound names from formulas. So first you write the name of the cation, and when the charge of the ion is not predictable, you use Roman numerals to denote the charge, and you crisscross backwards to get the charge. We'll do some examples of this, but you should write this down. And then you write the name of the anion. Now the ending for monoatomic ions changes to IDE, and if it's not monoatomic, you use the polyatomic ion list. So let's do some examples to explain this. So K is potassium. K is potassium. And then we have PO4 3 minus, which is polyatomic. So we're going to look on our list for PO4 3 minus. So it's phosphate. And there's our answer. Very simple. On the next example, there's NH4, so we see that's polyatomic. And there's only one polyatomic cation, so you have to look for it on this list. And notice it's right there, ammonium, NH4+. So we're going to write ammonium. And then you see an O, which refers to oxygen. You see it's right there, oxygen. You just change the ending to IDE because it's monoatomic. OXIDE. And there you go. There's the name, ammonium oxide. Next one is FeS, and we know that when we look at our periodic table, Fe is iron. So you write iron. And S is sulfur, so you change the ending. So it changes to IDE, sulfide. Now we notice on the periodic table that iron is in this transition area, which can't easily be predicted. So you have to write what the charge is. Now, the key to this is crisscrossing backwards. So you take this charge, which this number down here looks like a 1, right? So Fe would be +1. And then if we crisscross this one backwards, S is -1. Well, we know that S is not -1. S is -2. So to balance it out, Fe must be +2. If we take a look at this going backwards, this will be a little bit more obvious. If Fe is 2 plus and S is 2 minus, we know this S has to be 2 minus we crisscross this way, and we got Fe2, S2. But you know that these reduce down, so that means this iron has to be 2. It can't be 1, because that means S would be -1, and that's not the case. S is always -2, so to balance it out, iron has to be +2. Okay, and the last example here for this video is CuSO4, and you see Cu is copper, so I'm going to write copper, and SO4, we need to look it up on our polyatomic ion list, so we look up SO4 2-, you see it's sulfate, and now you need to figure out what to put here in parentheses, and you have to figure out why do you put it in parentheses. Well, you see it's in this transition area, so you have to write Roman numerals. So we take that number, which is a 1, put it up there, and ask ourselves, is SO4 1-? When we look at SO4, no, it's not. It's 2-. So if SO4 is 2-, to balance out the charge, copper has to be 2+. Copper has to be 2+. So I'm going to put a 2 right there. So there's the answer, copper 2 sulfate. I've put the handouts as practice on the Moodle and the TeacherWeb website, so you can practice those and ask me about them in class. Have a good day.